The main purpose of today's discussion is to understand the actual discharge flow can be used as a surge control in compressor. So let's start the discussion. This is a arrangement of compressor where compressor takes suction from either atmosphere or from the process gas. It has inlet guide vane and a compressor can be single stage or multi-stage. And in the final discharge, when FT is installed, flow measuring device is represented as FT, and close to FT one pressure transmitter PT and temperature transmitter TT are installed. And we have anti-surge control valve which is venting to atmosphere if it is air compressor, and it is connected back to suction of the compressor if it is a process compressor. On discharge side, one check valve is installed and discharge valve, and finally it is connected to discharge header. So surge control for actual discharge flow. FT is the flow measuring device. Measuring, it is measuring. Please read, it is wrongly written. Flow measuring device at the discharge of compressor in millibar. It can be any other unit. PT is a discharge pressure of compressor close to that FT. It is bar gauge. Temperature is discharge temperature of compressor close to FT. It is degree Celsius. PT, TT and PDT of FT are connected through electrical signal to PLC or DCS. In addition to these, all other instrumentation and control are also connected to PLC or DCS. Converting of PT, TT and PDT in engineering value in PLC, we know that how it is being converted. Then actual discharge flow is calculated based on the flow dp, pressure at flow measuring device that is PT, and temperature at flow measuring device that is TT. So actual discharge flow Q is equal to K into square root of dp into P, dp into T upon P, where Q is the actual discharge flow in meter cube per hour, P is the pressure at flow element that is bar absolute, T is the temperature at flow element that is degree Kelvin, dp is the differential pressure in flow meter in millibar, K is the flow element constant that depends on pressure, bar absolute, temperature degree Kelvin, and dp millibar. Surge test data. Surge test of compressor is conducted for minimum 3 IG position maximum to any number of points. Actual discharge data are collected during the surge test in the field. Surge actual discharge flow is calculated by taking the average of all the surge test data. Actual discharge flow through compressor is almost same in all surge test data. And K value is 736.909, which is calculated based on flow element device and pressure temperature dp. Surge actual discharge flow is 12,570 by taking the average of the all surge points. So these are the sample for the test. Surge point is 0.1234. Flow dp is 4.6, 5.9, 6.58, 8.6 millibar. Pressure is 3.79 bar gauge, 5.23 bar gauge, 6.29 bar gauge, 7.8 bar gauge. Temperature is 34.9, 34.9 to 34.96, 35.04, almost same. K 736.909. After putting this K value in calculating the actual discharge flow, in point number 1 it is coming 12,658. In point number 2, 12,572. Point number 3 it is 12,278, and point number 4 is 12,779. So in all the surge test, actual discharge flow is coming almost same. So taking the average of all 4 points, it is coming at 12,572. Surge lines. Surge actual discharge flow is calculated taking the average of all the surge test data, and surge actual discharge flow is 12,572. So if you draw the graph on time versus actual discharge flow, so actual discharge flow is the same with time, so it never changes, it is kept constant. Surge control line. So surge actual discharge flow is 12,572 meter cube per hour. Let's say surge safety margin on surge is 10%. So surge safety margin will be 12,572 into 10 upon 100 is 1,257 meter cube. So surge control flow will be surge flow plus surge safety margin. So surge control flow will be 12,572 plus 1,257 is equal to 13,829 meter cube per. So we can say this is surge line of 12,572 and 13,829 is a surge control line. It is time base, axis is time and y axis is the actual discharge flow, and if machine is operating above the surge control line it is safe and below this is not safe. Operating point, operating actual discharge flow is 16,000 meter cube per hour. Let's say this is above this, so it is safe because it is above the surge control line. PID controller, proportional integral and derivative controller developed in PLC or DCS. Input data are process value, PV and set point. One controller output. Output of PID controller will give command to anti-surge control valve through 420 milliampere electrical signal to positioner of anti-surge control valve to operate it. Process value PV is operating actual discharge flow meter cube per hour, and set point is average of all the surge test data of actual discharge flow plus surge safety margin in meter cube per hour. So PID logic, if PV is greater than SP, then anti-surge control valve will close. If PV is less than SP, then anti-surge control valve will open. If PV is equal to SP, then anti-surge control valve will be in the last position. So anti-surge control valve operation, let's say assume operating actual discharge flow is 16,000 meter cube per hour. Surge actual discharge flow is 12,572 meter cube per hour. Let's say 10% margin, so 12,572 into 10 by 100 is 1,257 meter cube per hour. Surge actual discharge flow with margin will be surge actual flow discharge flow plus safety margin, which is coming as 13,829 meter cube per hour. So set point will be surge actual discharge flow with margin, so 13,829 meter cube per hour. Process value is operating actual discharge flow is 16,000 meter cube per hour. So you can see this is the surge line, this is the control line, and this is the set point. PV is 16,000, which is above this. So PID logic, if PV is greater than SP, so 16,000 is greater than 13,829. So PV is greater than SP, the anti-surge control valve will close because it is safe zone. So if compressor operates above the surge control line, it is safe and anti-surge control valve will be closed. However, if operation is below the surge control line, below this, it is not safe, and so anti-surge control valve will open. So thank you. With this I have finished my lecture. Hope you like this. If it is so, please subscribe my channel, like it, share it, so that you can get the intimation of my new videos. See you in the next discussion. Till then, bye bye. Thank you.